Let's do this lab problem from section 4.2. This is problem number 1. It says to illustrate the mean value theorem with a specific function, let's consider the function f of x is equal to x cubed minus x from a equals 0 to b equals 4. And then it says since f is a polynomial, it is continuous and differentiable for all x, so it certainly is continuous on the closed interval a 0, 4, and it's differentiable on the open interval 0, 4. So notice that those are the conditions for the mean value theorem. Therefore, by the mean value theorem, there is a number c within this interval 0, 4 such that, and this is a statement of the theorem over here, f of 4 minus f of 0 is equal to the derivative at some unknown point right now, unknown c value, the derivative at that point times 4 minus 0. So in this case, a is equal to 0, b is equal to 4, and following the mean value theorem formula, we have this expression. So now we need to fill in some lengths. F of 4, we want to put 4 in here, so 4 times 4 is 16, times 4 I believe is 64, and then we have 64 minus 4, that's going to give us 60. F of 0, we put 0 in for x, and I believe that's just going to be 0, and now we actually have to take the derivative. The derivative is going to be 3x squared minus 1. Oops. Let's try that again. It's 3x squared and then arrow down minus 1. Hopefully that worked. There it goes. So that's your derivative. And so right now we're going to put in on the left hand side of the equation, we have f of 0 minus, or f of 4 minus f of 0, so that's 60 minus 0. And then f of c is equal to this times 4 minus 0. So that's what that is. Now they want us to fill in the number or the expression next to 4, which is going to be 3x squared minus 1, except we have to evaluate it at c. So that's going to give us 3c squared minus 1. And then we're going to multiply that times 4. So I think that's just going to be 12c squared minus 4. All right. So we got that worked out. So 60 is going to equal to this, and I think we just need to solve. So maybe I'll write it down here. We have the expression 60 is equal to 12c squared minus 4. I think I want to add 4 to both sides, so this is going to be 64. And then I need to divide by 12. So reduce maybe. Half of 64 is 32. This is going to be 6. We could take half of that again. That's going to be 16 over 3. So let's try 16 over 3. So c is going to be plus or minus. If you need to take the square root of that, that's going to be 4 over square root of 3. But c must be between 0 and 4, so the positive part isn't going to happen for us. And so we're just going to take a look at the negative part isn't going to happen to us, so it's just going to take a look at the positive part. So the figure illustrates the calculation. Let's check our answer. So that all looks good. I actually did this in Desmos so that we can kind of see a live graphic of it, and I set up my windows so that it kind of looks like this picture, and this is what we have. It's kind of close. And then what I have here is a point dragger, and what we're trying to illustrate with the mean value theorem is that you have the blue line, you have this given line as a line going from 0 to 4, 60. That's our point when x is equal to 4 on the graph, and then we have a secant line. And what we're doing is we're trying to find an x value so that the secant line and the tangent line is going to be parallel. So just roughly speaking, it looks like it might be 2.3-ish would be the value that we're looking at. If we go a little bit past that, it's definitely not going to be parallel anymore. If I go a little bit before that, it's not going to be parallel. So the question is, what x value point can I pick so that this is actually parallel? Well, turns out that 4 divided by square root of 3 is equal to about 2.3094. So 2.3 is our estimate over here, and then it looks like we got a pretty good number. And to get the exact number, it's 2.3094. So the mean value theorem looks for a point so that the tangent line is going to be parallel to the secant line. All right. Okay, that's it. I hope that helps.